So now that you know how to graph polar coordinates, we need to look at how do you convert. For instance, how do you take something that's been given to you in polar, in r theta form, and convert it into good old rectangular xy form for the Cartesian plane like I've got here? Or alternately, how do you go the other way around? How do you start with something that's in xy form and convert it into r theta form to put it on a polar graph? So let's take a look at an example. Here I have point L. It has a radius of 5. The direction angle is negative 135 degrees. So as we saw in the last video, that means I'm going to go to negative 135 degrees, like so, and then I'm going to go out a distance radius of 5. I'm going to go to an angle 135 degrees negative. Negative means clockwise. And then I'm going to go out from there 5 units on the rings, and that's how I would graph that point. So you can tell right away that point has to belong right here in quadrant 3. Now, how do you find the coordinates? Well, you actually already know the formulas because you used the formulas when we did vectors. X is r cosine theta, and y is r sine theta. And you already knew those from last week when we did vectors. So now we're just going to plug in. So if I can get some help from my assistant, I need r cosine theta. What should I put as r? Oh, I don't need a calculator. This is on the unit circle. I've memorized it.
Obviously.
So
Your radius is 5.
So my radius is 5. And then I need the cosine of?
Negative 135.
Negative 135 degrees. And I have memorized the unit circle, so I know that the cosine of 135 degrees is negative square root of 2 over 2. So I have right here that x is 5 times negative square root of 2 over 2. So in other words, 5 root 2 over 2 negative is my x component. Now, here's where I might need a calculator though. I'm not quite sure how many 5 root 2 over 2 squares are. So here's where we reach for the calculator.
Oh, it's right there. Okay. Okay.
There you go, ma'am.
Yes. Okay. 5 square root 2, negative 3.54.
So that's the x part of my point, negative 3.54. And remember, I'm expecting my point to be in quadrant 3, so having a negative x makes sense. Now we go for y. Y is r times the sine of theta, the radius is still 5, times the sine of the angle is still negative 135. And again, I happen to have memorized the unit circle, so I know that the sine of negative 135 is actually the same as the cosine of negative 135. It's negative square root of 2 over 2. So I have 5 times negative square root of 2 over 2, which gives me negative 5 root 2 over 2, or in other words, negative 3.54 again.
Okay.
And so now that point, I'm going to go over 1, 2, 3 and a half, and then go down 1, 2, 3 and a half. And so there, right there, is point L in quadrant 3, as we predicted. Now, I took the lead on that one, so it's definitely your turn
Definitely
to
my
try
turn.
out K.
All right.
All right, so K says it's at 6, 2 pi over 3. So what quadrant are you expecting to see your point in? Let's see, 2 pi over 3, that's 120 degrees.
120 degrees is over here, so quadrant 2.
So we're expecting an answer here in quadrant 2. All right, let's see if that's what we get.
All right, so x equals, I'm very short.
Only compared to me.
Cosine theta, which equals 6 times the cosine 2 pi over 3. I did not memorize the unit circle, so I do not know what that is.
Tragedy, that is negative 1/2.
Okay. Times negative 1/2, which equals negative 3, which is not weird because it's in quadrant 2, so it's a negative x. So that works.
Cool.
Then you got y equals r
I'll make some space for you here, ma'am.
Thank you. I'll write it up there then. Okay. Y r sine beta, that equals 6 sine 2 pi over 3.
Which is the square root of 3 over 2.
6 times square root of 3 over 2, which is 6 square root of 3 over 2. That can be simplified. So that cancels. So that can be 3 square root 3.
And 3 square root 3 is the exact value. But just so we know where to draw it on the grid, we're going to go to the calculator and simplify that.
3 square root 3 is 5.2 5.2. Y is positive, which means it falls in quadrant 2. So go over 1, 2, 3, and then go up 1, 2, 3, 4, 5, and like a little bit 0.2. So point K should be like right there.
There's our point K in quadrant 3 as we expected. Okay, now what about going the other way around? Well, we can do that. We can totally do that.
Yep.
The math is going to get a little bit different. But again, it's going to be math that you've already practiced with vectors. So don't worry. I'm not showing you any formulas you haven't seen before. So here is my point. My point is 4, negative 3. 4, negative 3. And I want to find where that goes on a polar graph. Well, first of all, I'm just going to think about it for a minute. This time, this is in regular XY form. 4 is the X, Y is negative 3. So that means I'm looking at a point that is here in quadrant 4. So how do I find that point on the polar grid? Slide that up just a little bit there, make some room. So first of all, I want to find the radius. Well, I have good news for you. The radius is the formula you already know from vectors. Pythagorean theorem, square root of x squared plus y squared. So that will be the square root of 4 squared plus 3 squared. I'm not going to bother to write the negative because when I square it, the negative goes away anyway. So I get 16 plus 9 gives me the square root of 25, which is 5. So the radius here is 5. Now, this picture only shows 1, 2, 3 rings, so what I'm going to do is I'm going to have each ring represent 2 units. So this is 2, 4, 6. There's no rule that says the rings have to represent 1 unit. They can represent more than 1 unit. They can represent a fraction of a unit. You just have to put a scale to make it clear when you do that. So 2, 4, 6 means I'm out here somewhere between ring 4 and ring 6. But I still need a direction angle. So how do I get that? Well, again, I'm going to use a formula that I already know from vectors. Theta is the arctangent of y over x, and add 180 degrees if you are in quadrant 2 or quadrant 3. Now I'm in quadrant 4 right now, so I don't need to add 180 degrees. So theta is the arctangent of y, which is negative 3, over x, which is 4. And this is not something that's on the unit circle, so I have not memorized it. She was waiting to see if I had. But we'll go to the calculator and find the angle.
Negative 36.9.
36.9. So we're just going to round that to negative 37 degrees. Negative 37 degrees. Okay, so here is 0, and we're counting by 15, so that's 15, 30, 45. Here's negative 30. Here's negative 45, so it's got to be somewhere in between those two. And I need to go out 5. 2, 4, 5. So there is my point M right there, which you'll notice looks a whole lot like my quick sketch I did over there. And now we have one more to try together, folks. So here we go.
All right, it's my turn.
This time's your turn, and I gave you some nice juicy numbers to work with.
I see that.
I did. I didn't want you to be bored.
Oh, never bored, sir. Okay, so quick sketch of Mr. Monkey. So it says -2, -2 square root of 3. So they're both negative, so it'll be in quadrant 3. So
You got it.
So that'll be where it should be located. So we're gonna find the radius. R equals the square root x squared plus y squared, which is -2 squared plus -2 square root of 3 squared.
And notice how she's putting parentheses around the number before she squares it. Those parentheses are important. By all means, take that to the calculator.
Right. So I know what -2 squared is, but I don't know what -2 square root of 3. Oh, okay. This is 4 plus 12. And that's square root of 16, which is 4.
So our radius is 4.
Yes.
We've got our radius.
Okay.
Awesome.
Now to find theta. Theta equals arc tan of y over x. And since it's in quadrant 3, we're going to add 180 degrees.
Notice what she said there, folks. We're in quadrant 3, so we're adding 180 degrees.
Yes.
Do that in quadrant 3 or 4. I mean 2 or 3. 2 or 3.
So arc tan of -2 square root of 3 over -2 plus 180 degrees. Go to the calculator because I do not know that. 2 square root of 3, 240 is theta.
240 degrees. And what quadrant do we find 240 degrees in?
240 degrees is in the 3rd quadrant.
Ah, just like you predicted.
Yes. And since we don't have 4 rings, I'm going to count by 2s. 2, 4, 6. And we go to 240 degrees, just here. And then we go out radius of 4. So 2, 4, the point is right here.
And there is our point in quadrant 3, just as you predicted. And that, folks, is how you convert between a point that is in rectangular into polar, or in the first 2 examples, from a point that's in polar into rectangular. So now we know how to graph points on a grid. We know how to graph points on concentric circles. We know how to convert between the 2. The next thing we need to do is try graphing some functions, and that's your next video.